AI made the decision. The connection dropped. 10,000 emergency calls didn't get through. The regulator asks why.
That's the part nobody's solving yet.
I'm Giga.
I'm Byte.
Welcome to Volume 2 of the Substrate Report, Trust at the Edge.
Episode 2. Last episode, AI becomes the design center of the network. Cell tower becomes edge data center. The architecture works.
This episode is the part most operators are sleepwalking past. Once the network is making AI decisions on a 10-millisecond budget, picking modulation, routing emergency calls, allocating GPU pools, every decision needs to be auditable.
Because some of those decisions affect critical infrastructure, autonomous driving networks, smart grids, industrial robotics, URLLC, ultra-reliable low-latency communications. The fail modes are serious.
The EU AI Act made it law. Critical infrastructure AI is high risk, mandates audit trails, explainability. You cannot have the neural network decided as your answer when a regulator asks why 10,000 emergency calls dropped.
AI's strength is pattern matching at speed. Its weakness is explaining itself. Pre-AI networks were rule-based. You could trace why a connection dropped. Neural models don't have rules, they have weights.
So you add explainability, SHAP, rule fit. Shapley values mapping decisions to features.
But near RT, RIC operates on a strict 10-millisecond loop. Computing Shapley values for every packet schedule violates that budget immediately. The network can't decide and explain in the same loop.
Put XAI in the live path. You crash the network. Don't. You fail the audit.
The fix is to move XAI out of the live inference path entirely into the asynchronous federated learning pipeline.
Local Open Central units train their models on local cell site traffic. They don't send raw data anywhere. They send updated mathematical weights to the non-RT RIC over the A1 interface.
The non-RT RIC only aggregates updates that pass a strict XAI confidence threshold. The global model pushed back down is inherently trustworthy. Regulatory compliance satisfied. Not a microsecond added to the 10-millisecond loop.
AI by design at the trust layer. Trust isn't bolted on. It's woven into the federated learning architecture.
Another fail mode. Neural channel estimators trained on idealized data. Additive white Gaussian noise. Deploy them into a real city. Rayleigh fading, Doppler shifts from high-speed trains, severe weather, patterns the model has never seen.
The confidence matrix collapses. The model doesn't degrade gracefully. It drops the connection.
3 layers of resilience. Low roux-style channel adapters that update 3.5% of parameters on the fly. Network digital twins for synthetic stress testing. Ray tracing data validates the model before it touches live spectrum.
And as a hard floor, 3GPPRRC capability negotiation drops the AI native physical layer and reverts to traditional OFDM and LDPC coding when AI confidence collapses.
Explainable in async, adaptable in real time, gracefully degradable when reality breaks the model.
This is the trust frame substrate-aware networks were built for. The network knows what it's carrying and what trust attestation that data requires.
Identity layer carries the attestation chain. Federated learning carries the model lineage. 3GPP fallback carries the deterministic safety net.
Trust isn't a feature, it's the architecture.
Same pattern in automotive. Every steering decision auditable. Same in energy. Every grid action explainable.
Episode 3 closes Volume 2, AI by Design Beyond Telecom.
Volume 2, Episode 2, Substrate Report.
Anchor on. 34 degrees.